Hello everyone, in this video lesson I'm going to show you how to work with the hot standby router protocol. First of all, let's take a look why do we need to have the hot standby router protocol like an HSRP. And by the way, this protocol is the Cisco proprietary protocol and it can work only with the Cisco equipment. And imagine that you have PC1 which is going to communicate with the PC2 and they will be interconnected with router 1 and router 2. And as you know that we have to have the file gateway for the PC1 and the file gateway for the PC1 have to be one of these two routers. So that if this router is going to have, router 1 is going to have an IP address 192.168.10.1 with prefix 24. Okay, then you will configure your device with the file gateway, and you will type here 192.168.10.1. So if your PC1 will not be able to, will not know the IP address of the file gateway, then PC1 will be able to communicate only with devices which are inside this network, like with the PC3, with this router, and that's it. Well, and now after we defined our default gateway for PC1, our PC1 will be able to communicate with PC2 by using this router. So our communication will go here, and when we will have reply, so in case if our IP address of router 1 gigabit 01 will be equal to 20.1 with prefix 24, and if we'll configure PC2 with default gateway 192.168.20.1, then our reply, so let me change the color, so our reply will go by using this way. Alright, but what if we will have an issue with the link between switch 1 and router 1, for example, if something will be wrong here. So then we'll not have communication with external network. I mean, PC1 will not be able to communicate with external network. And we can provide to our computer, PC1, that it will know also the file gateway as the interface of router 2 gigabit 00, and for example its IP address is going to be 192.168.10.2 with prefix 24. So then to use the services we have to just change our configuration to so that the file gateway will be 2. But in this case we are making a manual configuration and it will take time actually. It's not so comfortable to to enter the computer and change this configuration, and after you will learn that your router is not working, I mean router's interface gigabit 00 is not working, and only afterward your communication now will be able to pass by using this way. Alright, but you can have also the issue, that PC2 will not be able to communicate with PC1 now, because PC2 will send a reply right to this side, and it will cause a problem also, because router 1 is not connected now with the PC1. So that you have to also reconfigure your PC2 that it will not use this default gateway, but it will use the file gateway, which is the IP address of the gigabit 01 interface, so that your communication will be redirected to this side. Well, you can solve this problem manually, as I showed you, or you can use the services of the HSRP protocol, which is doing the same job automatically. And how it is working. So let me also delete this part and this. Well, all you need to do, you need to configure the HSRP or standby protocol on your router interfaces. And so look, this IP address belong to gigabit 00 interface of router 1, and this IP address belong to gigabit 00 interface of router 2. So let us define them like this. And in case when you configure the standby protocol, what do you need to do? You need to enter to the interface and configure the standby configurations. And by the way, before starting to make the configuration, let me show you the characteristics of the HSRP version 1 and characteristics of HSRP version 2. And at this time, we'll also describe the algorithm of how HSRP protocol is working out. So HSRP protocol is using, if we are speaking about version 1, then HSRP protocol works with the multicast address 224.0.0.2, which is actually may have a conflict with CGMP protocol. And what does it mean? It means that router 1 sends update to switch, which is traveling to IP address 224.0.0.2. And this request, this update will go to router 2, and router 2 will send periodic update to router 1. Okay. Well, we may have from 0 to 255 groups, so we can create multiple groups inside the router, which will work. So each of this group will work separately. And also we have the MAC addresses, the virtual MAC addresses that are used by the HSRP protocol, starting from this value and ending with this value. And actually it depends on the group number, and for each group members we will have the same MAC addresses. For all group members will have same MAC addresses. And for example, in case when router 1 and router 2 are working in single group, so this part will be working with the single group, for example group number 1, then their MAC addresses will be equal to 0000, 0C07, and AC01. And in case when your router's interfaces gigabit 01s will be configured with HSRP 2, and if they will work with group 2, so for example group 2, their MAC addresses will be 0000, 0C07, AC02. So both of these MAC addresses will have same both of these two interfaces will have same MAC address from this side and the same MAC address from this side, because they can use different groups. And what about timers? They get timers. The hello timer takes 3 seconds by default. What does it mean? It means that router 1, if it is configured with the standby protocol from this side, router 1 will send hello message to router 2 every 3 seconds. And if this message will not be delivered for more than 10 seconds, then router 1 will think that router 2 is not available, and afterward maybe some changes can be occurred in the network. And hello timers can be configured from 1 to 254, whereas the hold down timer, the maximum time of checking the existence of the router is from 2 to 255. These are characteristics of HSRP version 1. Now let's take a look for characteristics of HSRP version 2. In comparison with HSRP version 1, second version works with a different IP address, multicast IP address, and it doesn't have a problem with any other protocols. And group number is extended. Now we have group number from 0 till 4095, and MAC address also increased in size, so that now we have from zeros till 3Fs. And by the way, if we'll take a look for this side, so we have 256 combinations here. And to gain this 256 combinations, we have actually with you two hexadecimal values. And this is not just the decimal value, it is hexadecimal values. And if you'll take a look for 0, 0, in binary, they will be looking like 1, 2, 3, 4, and 1, 2, 3, 4. So totally we have 8 bits, and so we have 8 bits. And by using this 8 bits, we have 2 to the power of 8, which is giving us 256 combinations. Well, whereas in HSRP version 2, we have 4096 combinations, 4096 combinations. And these combinations can be gained by the 3 hex text values. So if you'll take a look for 3 zeros, and if you represent them in the binary form, then you will see that you have actually 12 bits, and 2 to the power of 12 is giving you 4096. Well, let's check it out. 2 to the power of 12. Yeah, here it is. And we have same timers for hello and for hold down timer. And actually the logic is the same as in HSRP version 1. HSRP version 2 is just enhanced version of the protocol, which is giving you ability to connect more groups. And these groups can be associated with different VLANs, because this number is extended. Okay, so you may have so many groups. I mean, you may have same IDs of groups as your VLANs. It is easier to work with these numbers. Now let me show you how to configure the HSRP. First of all, our idea in this example is to configure HSRP on router 1 and router 2 on these two interfaces, gigabit 00 and gigabit 01. First of all, let me tell you that one of these routers will be elected as the primary router, as an active router. So let's say that we will have one active router in this example, and we will have one standby router. So it means that your communication will be happening, for example, like this all the time. But if something wrong will be with this link, then PC1 will send information by using this way automatically, without the need of reconfiguring your devices. And how to do it? First of all, we'll enter to the interface of the router 1. Global configuration mode. Afterward, we'll go to gigabit 00 interface, and next we'll say to this interface that this interface is going to have the configuration of the standby. So you will never see in this operating system HSRP words, you will just see standby, and it stands for this letter. And afterward, you have to define the group. So if you are using version 2, then you have available 4096 combinations for the groups. And if you will not write the group ID, then it will be by default group 0. So let us have a group number 1. And afterward, we will say that this standby group number 1 will work with the virtual IP address, which is going to be configured as 192.168.10.100. And by the way, let me define that here we'll have IP address 10.1 with prefix 24, and here we'll have IP address 10.2 with the same prefix 24. So, and whereas our IP address of PC1 is 10.10. Alright, so we configured the router 1's interface gigabit 00 with the standby protocol. And afterward, we have to also provide the configuration of it. Like we'll write standby, we'll define the group number, and we'll define the priority. And in priority, we have a variance of the priority. It is from 0 till 255. And so you have to select one of these values. So if you will not define the priority of this standby group on this interface, then its default priority will be 100 by default. So, and due to that fact that this is not metric, the highest priority will be the best priority actually. So if you have priority 100, then it is a standard default priority. If another router will have priority which is higher than 100, then that router will become active. And this priority is used, so let me change the marker. Priority used to define will this interface be active or standby. Will be primary or is the secondary, let's say like this. And in case if the priority of another router, like router 2, will be lower than 100, then router 1 will become inactive. In vice versa situation, router 1 will become a standby router. What else we can do? We can also configure the version of the protocol. So we'll just write standby and we'll write version and we'll write 2. Okay. And what else? We also can make configuration of timers. And timers, and afterward, for example, we want to change timers of hello packet from 3 to 5, and we will change the timer of the hold timer from 10 to, for example, 15. So this value is the hello timer, and this value is the hold timer. And what else we can make the configuration? And now it's time to make configuration of router 2. So I'll just take these configurations, and for example, let me write here for router 2. I will write same configurations. Configs excluding this one. I'll write in router 2 in configuration of interface FA00. I'll write here configuration of the priority, so I'll change it to, I'll write standby 1. Priority will be not 100, but it's going to be, for example, 95. So we define it here, the priority. So let me write priority, which is equal to 95. And here we didn't change anything, so that the priority by default is 100. So this priority make a difference between these two interfaces. And this interface becomes active gateway. And this interface is becoming now a standby interface. And when PC1 will try to make communication with PC2, communication will travel now by using this link. And actually, by the way, due to that fact that both interfaces will have virtual IP address, so this IP address is actually a virtual IP address. And our physical IP addresses are represented here. So this is physical and this is also physical IP address. And as you see, they are different. On their physical interface, their IP addresses are different. But Virtually they have same IP address, and virtually they will have also same MAC addresses. And when PC1 will send the information to PC2, and actually this will be happening in this way. So we'll have a multicast communication starting from the switch. And afterward, router 1 will resend this information to PC2, but router 2 will not do it. Okay, and all the time your PC1, when it will try to make communication with PC2, it will send a multicast request, and this multicast request will reach both of these routers, but only one router will resend this information to the destination. Alright, let's have a small example of how to configure this HSRP. Well, I prepared for you the small topology, and let me first of all take all configurations off from the routers. So now I just deleted configurations from router 1. And also I have to provide now the IP address configurations of the two computers. They are going to be 192.168.10.10 with subnet mask of prefix 24, and the file gateway will be 10.100. And now, let me also configure my interfaces with IP addresses. They are going to be 10.1 with prefix 24 and 10.2 with prefix 24. So from the right side, we'll have IP addresses 20.1 with prefix 24 and 20.2 with prefix 24. So all I need to do currently, I just need to make configuration of my routers interfaces, physical interface IP addresses, and IP address of computer 2. So let me start with the task of the configuring computer 2, and it's going to be 2020 and 192.168.20.100. And now I would like to do this job with the notepad. Oh, sorry. In Notepad, I will write configurations of router 1 from the beginning. So we'll start from the host name R1, and afterward interface gigabit 00 will turn on, and we'll give an IP address for that interface, which is equal to 10.1 with subnet mask of prefix 24. Afterward, I'll just copy this configuration of gigabit 00 interface, and my next job is to implement the configuration for interface gigabit 01, whereas IP addresses are going to be a little bit changed out. So now this is configuration of router 1, and now I have to pre-configure my router 2. So here I'll place the breaking line between these two routers configuration, and router 2 and gigabit 00 10.2 and 20.2. Now I have to just copy this configuration and paste it to router 1, where I will place these configurations. I will paste them in global configuration mode. So all I need to do, just click to paste button. Now let me save my configurations by using command WR or write. And let me select these configurations of the second router, and let me paste them right here in the global configuration mode also of router 2. So look, don't forget to place it in global configuration mode. And now it's time to just fast forward time, and we'll go to router 1 now. And in router 1 we have to take a look for the routing table to be sure that we have configured our interfaces properly, and that router 1 is able to communicate with both of these networks. So we'll just write show IP route, and we need to have only connected network. So 10.0 network, which is from the left side, is available for router 1, and 20.0 network is available for router 1 from the right side. And also we can type command show IP interface brief to take a look for the IP addresses of our router interfaces, and they are 10.1 and 21. And now it's time to take a look how our router 2 is pre-configured. So we'll just write show IP interface brief command, and we will see that our two interfaces also get IP addresses, and they are proper IP addresses which we wanted to implement for them. And now it's time to configure our standby protocol. So as we mentioned before, router PC1 thinks about the default gateway IP address like 10.100, and PC2 knows the default gateway as 20.100. So we pre-configured them. So if you'll take a look for this PC configuration, so you'll see that this is the file gateway. But physically we don't have this interface. We don't have this IP addresses. All we have 10.1, 10.2, 22, and 21. Now it's time to make configuration of the HSRP protocol on router interfaces. First of all, we'll go to configure interface gigabit 00, and we'll say to this interface that it will have a group 1, standby group 1, and afterward we'll define the IP address of that virtual IP address of that group, and it's going to be 192.168.10. Let me just change the size of it, 10.100. Maybe I shouldn't write here the address, so it's going to be just an IP. What else I have to do? I have to write standby. So if you don't know, or if you forget which command you have to type here, then you can just use this question mark as the hint. And let me write here standby group 1, and we'll just use here what we are going to use. Oh, and it's already showing us that our router became active router, because it is single router which is working with the standby right now. And also we have to provide the configuration of the standby, and we'll say that we'll use version 2. And you see that something is changed immediately because the protocol version type is changed. And also we have to provide the priority. So let's write a standby of group 1. The priority is going to be let's say that by default the priority is 100, but we'll do it 105. Standby. And what else we can use here? We'll change the timers like 5 and 15. Or let's change the timers back again, so that if you are changing timer in one router, then you have to change it on all other routers which are going to participate in this group, so that if you will not do it, there will be no synchronization between these two routers, and you will have some issues with them. So that imagine that we didn't change them, and I just place here default values. What else? Also, I recommend you to provide here information about preemption, so that in case if your router 1 will become an active router, and router 2 will become the passive router, if something wrong will be with the, if not something wrong, if the priorities are going to be changed in future, so that priority of router 1 will be less than priority of router 2, and if you want your router 2 to become an active router, then you have to write this command standby 1 and preempt, because in other case, if you will not do it, your router 1 will work as an active in case if it is working. If you are not writing preempt, router 2 can become an active router only in case when router 2 will not receive messages from router 1. But sometimes it can be happening that the priority is changed on router 1, it is working, but router 2 is not changing its role to the active. So to prevent the situation, if you want your network be really dynamically changed with this roles of active and standby, then I recommend you to write here the preemption. What else we have to do? Now it's time to configure router 2 with the standby protocol interface gigabit 0.0, standby version 2, standby 1 IP address is going to be 10.100. And what else we have to provide? And also we'll write here standby group 1 and preempt. We turn on the functionality of the preempt. We didn't change the timers. And now it's time to take a look of the result, which router became inactive and which of them became the standby. So the HSRP here configured with the priority, which is equal to 105 from this side, and from the button side, this interface gigabit 0.0 is configured with the priority. Actually, we didn't configure priority, and that is why by default it is taken priority of 100. So by measuring these priorities, routers exchange the HSRP messages, and afterwards router 1 defines that it has higher priority and takes the role of active router, and gigabit 0.0 interface of router 2 defines that it has less value of the priority. That is why it became the standby. Now let us take a look for the output report. So we'll just write show standby, and after what we may see here that we have a gigabit 0.0 interface on router 1, which is working with group 1 and which is working with version 2 protocol, and its state is active. Whereas router 2's interface, so let's take a look, show standby. Router 2's interface gigabit 0.0, which is working also with group 1 version 2, is in state of standby. And as you see here, also we have the virtual IP address 1 and 1. So if we'll take a look for these two routers outputs, so from left side we have router 1 and from right side we have router 2. And so let's compare them. One of them is active, another one is standby. They use same virtual IP address, and it's from here and here, and they use same MAC address, virtual MAC address, you see, and this is absolutely same. Why it is absolutely same? Because when computer 1 makes communication with computer 2, it is sending this packet to this side and to this side, because we have a backup gateway. And if something wrong will be with active gateway, our standby gateway can provide the connectivity immediately without losing the time. All right, and what else we can see here? We can see that timers are absolutely same, and it is very important for us. And now we can see the also active router is local, says router 1, and standby router's IP address, so this is physical address of router 2 is 10.2, and configured priority is 105 in router 1, and configured priority, like default priority on router 2, it is 100. So that is why actually router 1 became an active router. So now it's time to check how our PC1 will be able to communicate with PC2. But before starting to checking our connectivity between PC1 and PC2, we have to also change one more thing. So just not this one, PC1, just PC2. We have to change our configuration of PC1. I mean, we did not define the proper gateway currently because we don't have physical IP address 20.100, and we will select one of them. For example, I'm selecting gateway as the 20.1. And now we need to go to the simulation mode, and in simulation mode we have to select in filters. So we'll click to show all none button, and here is the filter of the ICMP. And now it is quite enough to just send the packet from PC1 to PC2. And packet, as you see, sent to router 1 and router 2. And router 1 will resend this information to the to the destination, like a PC2, and router 2 is just deleting it, because router 2 is currently, as we saw, it is in the standby mode. So, and let's see what will be happening next with this packet. Packet is delivered, and the packet is sending, so PC2 is sending the reply to PC2. All right. And also we can make the same operation by using the ping command, ping 192.168.20.20. So then we'll have with you multiple packages of the ping. So the first one came, and let's take a look for the second one. And every time, as you see, switch is just sending this information to both of the routers. Why it is sending information to both of the routers? Because our destination MAC address is F001. And as we mentioned before, so if we'll take a look for router 1 and router 2 configurations, so let's have the same package here. I mean the header of the frame, and we'll take a look, sorry, for the router 2's output. Show standby, and from this side we'll also type show standby. So from here we may see that MAC address of this router and MAC address of this router of this interfaces are same, F001, and where is our packet? And when we will see for our frame header, like to which MAC address it goes to F001. This is the MAC address of the this is the MAC address of our multicast HSRP, and that is why it travels to both of the routers, and only one router in this situation will just forward it to the to the receiver, sorry, like this. And now in case if something wrong will be happening with with the link between router 1 and switch 1, so let's have this example. So look, where is that button? Capture and forward. Information goes like this, and goes back again like this. Sorry, and comes back again by using this way. But if alright, so let's have that will be delivered properly, and if in one moment something wrong will be with switch 1's and router 1's link, then our computer is still sending information to PC2. So sorry, let's do it in this way. So you see, the packet can still be delivered by PC2, but we have issue in this situation that PC2 is giving a reply through only this IP address. So we did not use HSRP from the right side, and that is why router 1 will now send the message like destination host unreachable to PC2. And actually we will not have reply with you here, and we will see just only a request timeout message. So to prevent such kind of situation, we have to also configure the right part of our network. Now the network 20 is going to have also be involved with the HSRP. So I will just place here a rectangle. So this is group 1 and this is going to be group 2. Okay, so that our group 1 is having an IP address of 192.168.110.100, and our group 2 of HSRP will have an IP address 20.100. And all we need to do, we need to configure our router 1 and router 2 with the configurations of HSRP. And I'll just start to do it from here. Interface gigabit 01, and we'll say that standby standby IP address is going to be 192.168.20.100. And what else we have to provide? We'll say that standby 2, by the way, I forget to place here 2, group 2, and its priority is going to be let's say it's going to be 100. It's default priority. We will not change it actually on router 1, and also we'll turn on the function of the preempt. So this command is going to be implemented into router 1's interface gigabit 01, sorry, and in router 2 we'll implement this command, which will be 105. So let me just copy this command and let me go to configuration, global configuration of router 1, and let me paste it. From the other side, I will copy these configurations and let me paste them in global configuration mode. Now it's time to take a look for the output, the report of our standby protocol, which is showing us that we have now 2 groups, whereas in group 1, router 1 is active. So this is the end of group 1 of the report of the standby, and this is the beginning of the group 2 report. And in this report we see that from the other side, gigabit 01 interface is placed in standby, and its priority, so where is that? And it says that the priority of active router of router 2 is 105, and our priority of this router of router 1 is 100. And now let's take a look for the output of router 2. So we have also 2 groups, whereas in one first group, router 2's interface gigabit 00 is in group 1 and is standby, and in second group, gigabit 01 is in the state of active. And what does it mean? It means that our communication will travel, so our packet have to travel from PC1 by using this way, and it has to travel from PC2 to PC1 by using this way. Now let us just make the test of the ping. So we'll just call the command ping, and now if everything will be everything is properly configured, but it's not configured. PC2 still think about the file gateway as the 1, so we'll change it to the 100. And let me go again to real time and to simulation, so that PC2 will understand that it has new the file gateway. And let me make ping. Let's take a look. Packet travels to router 1 and router 2, but only router 1 will send it to the receiver. And PC2 gives reply, and this reply goes to router 1 and router 2 also, but router 2 only gives forwards this packet to PC1. So let's take a look one more time and one more time. So this is just the impact of the simulator of the packet tracer. Actually, this packet has to go also to the side. This is how it is working, and now it's time to check what will be happening, how HSRP will react on the network failure. So all we need to do, we need to make ping one more time, and while our ping is traveling, we'll change the structure of our network. So look, the first attempt, and before second attempt, we will, for example, delete this link, and our packet now goes to router 2, and router 2 is sending it to PC2, and PC2 is still able to communicate with PC1. So this is going to be our backup path, which is used by this packet. Let me show you another example in which we will make changes not from this side, but we'll make changes from this side. And imagine that router 1's link of the gigabit 01 will be damaged. So that in this situation, we have to we have to type the command which will track the status of the gigabit 01 interface on standby group 1. So that, let me show you an example. I think that it will be much understandable through example. So we'll go to configuration of gigabit 00 interface of router 1, and we'll write standby group 1, and we'll say track gigabit 01 interface. What does it mean? It means that the priority of gigabit 00 interface here. So let me write the priority of this. Priority is equal to 105. Okay. And if something will be wrong with gigabit 01, what does it mean something wrong? If gigabit 01 will be turned off, or if you just unplug the cable, then it is the same as it is turned off. I mean, its protocol is turned off. Then group 1's priority on gigabit 00 will be decreased for 10. So priority will be decreased for 10 units. So let's try to do it. And first of all, let's take a look for our standby output, in which we have to see that now we are tracking for interface gigabit 01. So look, gigabit 00 group 1 and track interface gigabit 01 state up decrement to 10 units. So what does it mean? It means that currently our configured priority on group 1 on gigabit 00 is 105. And if something will be wrong with the interface gigabit 01, our priority has to become 95. Let's check it. So I'm deleting this port, and let's go to the real time actually. And after it has happened, let's take a look one more time for our configurations of the group 1, which is configured on gigabit 00. And here we may find that priority is 95, but configured priority is 105. It means that our track worked, and due to that fact that our priority decreased to 95, and as you know, our priority on gigabit 00 of router 2 is 100, then what will be happening? Then router 2's interface has to become an active router. And let's take a look. Previously group 1 gigabit 00 on router 1 being active, now it is standby. And it means that now our communication, our ping will go by using the second pass, like this. So if you will not implement track on this interface to track this interface, then your priority will not be decreased, and if this priority will not be decreased, router 1 will still think that it is an active router, and router 2 will still think that it is standby router, and that is why you will not have successful communication. I hope that this video has been informative for you guys, and in case if you have any questions, do not hesitate to contact me by my email addresses, and see you again next time.